All right, new chapter, chapter 4, all about slope. So lesson 1, we'll be looking at slope of a line. First thing, definition of the slope here, we have that it's the rise over the run. The rise is a vertical change between 2 points, and the run is a horizontal change between the 2 points. Hopefully by this stage in our lives, we know that vertical means up or down, and horizontal is going this direction here. The slope of a line represents the steepness of the line. The greater the slope, the absolute value of the slope, that's why it has these guys here, the steeper the line is. The slope of a line can be a positive, it can be a negative, zero, or undefined. 4 different options. The variable m, so this is the variable, is used to represent slope. Meaning if I told you that slope was 2, you would write this down as the slope, m, is equal to 2. Or if I said that the slope of a line is 1/2, you would put m is equal to 1/2. Meaning that our rise would be 1 and our run would be 2. If we have a whole number or a whole integer here, let's say, we know that the number 2 can be put as 2/1 in order to make it into a rise over run type thing. So this would be our rise and the 1 would be our run. Now positive slopes go up to the right. See how this line here, from left to right, we start on this left hand side, and as we move to the right, our line is going up. And then it can also have a negative slope, and negative slope go down towards the right. So here our line, I know my sticky note is in the way, but we have our line, and we can tell that if we start here on the left-hand side of our graph, as we move to the right, our line is going down. So this here is a negative slope. Positive slopes go up to the right, negative slopes go down to the right. Okay. Little cheat sheet for you guys. All right, we talked about this being the rise over the run. The rise tells me to go up or down, and my run tells me to go to the left or to the right. Now, for our rise, if the number that's in this part of, I know this is a fraction looking thing, but on the rise section of my slope, if it's a positive change, meaning if it's a positive number, we are going up. If this number here is a negative change, we will be going down. All right. Our run now, so the number that's going to be on the bottom, so on this side here, tells me if I'm going to go to the left or to the right. And I'm sure that some of you guys can guess what's coming next. If it's a positive change, we are going to the right. If it's a negative change, we are going to the left. Okay. So with that being said, we're actually going to dive into some problems now. So problem 1, it says to find the slope of the line. And remember that slope of the line is the rise, oh, drop my pencil, is the rise over the run. I do apologize for the sniffles. Slope is m, which is equal to the rise over the run. So we need to count and look at our points. We need to pick 2 points on this line. And notice that the points that I need to choose need to directly hit the corner of my graph. So see how this point here hits the corner of my graphs this way, and then this one here hits at the corner of my grid lines there. I can't choose a point like, for example, this point right here. Yes, this point is on my line, but it's not at one of the corners or it doesn't hit a corner of my grid lines, so it's hard to tell what exactly is the rise over the run. Okay, so let's go ahead and break this down using these 2 points here. This point to this point. We need to count how many times we go up and then how many times we move to the right, it looks like. So my rise on this one will be represented by this pin. I need to count how many times this dot in red, hopefully. Let's see if this works over here. In red goes up one, two, three different times. So here we go up three. And it's positive because we're going up. And then I need to calculate my run. Right, from that single point where I go up, how many times do I go over to get to that point? I go to the right one time. I'm gonna put this here. To the right one time. So my run is 1. So this here is my slope, right? And hopefully we all know that 3 over 1 can be simplified down to just the slope of 3. And that's it for number 1. Okay, so let's go down to number 2. That goes through, it's not too bad. Number 2 says find the slope of the line. We have our points here that we give to you, here and here. We need to calculate what our slope is. And again, the slope is the rise over the run. So I'm going to count how many times I have to go down on this one. So at this point here, how many points I go down? 1, 2. Nope, looks like I went over one more. It's actually just 2. 1, 2. So here I go down 2. And then from this point on, I'm going to count how many times I go over to the right. Right? So this would be 1, 2, 3, 4, 5, and 6 different times to the right. So I come over here to my little slope. We said that the rise on this one, I went down 2. So that would be a -2 since I'm going down. And then I went to the right 6 different times. So that stays as a positive. So my slope on this one is -2 over 6. And hopefully we can know that this simplifies. If not, we can just hit it into our calculators and see if it simplifies by just putting -2 over 6 on our calculators. And then we can tell that it does simplify down to -1 over 3 as my slope. And this is our final answer because we want the simplified version of our slope. Number 3 says find the slope of the line. Okay, so here we can choose any of these points that hit the corner of my grid. You can choose this one to this one, or we could choose from this point to all the way down here. There is no wrong answer. But the first thing that we need to calculate is that we have to pay attention when the grid lines slash the axes are labeled, right? So here we can tell that we start at 0, and then on the y-axis, they're counting by, looks like 2.5s, because there's a line here, so this would be 2.5, then 5, 7.5, then 10, 12.5, 15, 17.5, 20. Okay, and then on the axis, on the x-axis down here, looks like zeros here, and we're counting by ones all the way here. They split in the middle, so this would be 0.5, 1, 1.5, 2, 2.5, and 3, and so on. Okay, so here we go. Let's pick a point. I'm going to go from this point here to this point here. So if I go down, I have to go down 2.5. One more, that would be 5 units. So here I went down 5. And then in order to get from this point over to here, I go over 0.5 or 1/2, and then 1 full unit. So I went to the right 1 full unit. Go back to my slope. My slope again is the rise over the run, which means that my rise, I said that I went down 5, so that I have to put -5. My run was a +1 because I went to the right 1 unit. And we know that this simplifies down to just -5. So m is equal to -5, or slope is equal to -5. Okay, here, looking at this line here, the y-axis and the x-axis, looks like on the y-axis they are counting by tens, because 0 is here at the origin. Next unit up is 10, 20, 30, 40, so on. On the x-axis, they're counting by 1, so normal. 1, 2, 3, so on. Okay, so let's go from this unit here to, let's say, I don't want to choose this guy because you see how it's floating right in the middle-ish, right? I want to choose a line or a point that hits directly in the corner. If I notice this one up here, this one also doesn't hit in the corner, but our point all the way up here somehow does a little bit. So we can use any of the points that we would like. Okay. So this one here, I start off, let's go to, I'm going to say I'm going to go to this point here in the corner. Oh, actually, it doesn't necessarily hit it, because that would be 70 and then 9. Yeah, it doesn't necessarily hit it. So let's go ahead and do this guy here. From 0 to get to this point here, we have to go over 10. And it looks like it's just about here, right? And we know that our points are going up how many spots? A good way to tell, since none of these points necessarily hit the corner, is see how this one's at 20, this one's at 36. So in order to go from 20 to 36, we have to go up 16. And then I would go over 1 2 different times. So I would go to the right twice. So again, my slope is the rise over the run. I said that my rise on this one was 16 and the run was 2. And again, if we don't know that that simplifies down, you can always just hit it to your calculators to double check. But 16 over 2, we can see that our slope simplifies down to 8 for our final answer. Okay, back page. We have a horizontal lines have a slope and vertical line. So we're looking at this line right here. See how it's a horizontal line? We're used to seeing our vertical lines that go across our page with a positive slope, or a line that goes down with a negative slope. But with these guys here, when you see anything that looks like this guy here, where it's a horizontal line, you must know that the slope of the line is 0. Looks like the computer froze, so just gonna wait till it comes back. There we go. So horizontal lines have a slope of 0, while vertical lines, so lines like this guy right here, these guys have a slope of an undefined. So you must put undefined for any time you see a vertical line. Because technically, if I were to do the whole rise over the run, there is necessarily no run I can choose to make this correct. But let's say I want to go here and I start here. My rise here would be 0, right? Because I don't go up or down. And then let's say I wanted to go to this point right here. I would go over 1, 2, 3 different times. So my run would be a slope of 3. And then we know that anything with a 0 on top is 0. And if we didn't, we put 0 into our calculator over 3 and we get 0. So that's why anytime you see a horizontal line, the slope is just 0. And with this guy here, let's say I want to go from this point and go to this second point here. All right, my slope again is rise over the run. Here, my rise would be, let's say, 1, 2, 3. I go up 3 different units to get to that second point there. 1, 2, 3. My run would be 0 because I don't move to the left or to the right. I just stay on that same exact line. And then if I put this into my calculator, 3 over 0, notice the difference between the two. 0 over 3 gives me 0. But if I put 3 over 0, my calculator tells me math error. That's why my slope is undefined because I can't have a 0 down there. Okay. Finding the slope of a table. Slope is, again, the rate of change is another way of saying slope, where the rise is the change in y values, and then the run is the change in the x values. Now we show this formula because, I mean, imagine writing this several different times. In math, we like to make things a bit shorter in a sense. So a quicker way to write this formula would be with this little triangle here that represents the word change, the change in y, all over the change of x. Meaning, we have a table, and we know that slope is the change of y over the change of x. We have to go to the y section of my table, and here it's labeled right here, that's why it has the y. And I have to find the change between going from a 12 to a 9. Okay, so if I start at 12 and then I go down to a 9, what exactly happens? Hopefully you're thinking we subtract 3. The same thing here, from 9 to go down to a 6, we would subtract 3. From a 6 to a 3, we would have to subtract 3. So right there, this process right here is that top part of my slope. The change of y I know is a -3. And then I move on to the change of x. X is over here, that's what has the x there. And I want to ask myself, start at 1, and then I want to go to 3. So what must I do? Right, from 1 to 3, hopefully we know that we're adding 2. From 3 to 5, I know that I'm adding 2. And 5 to 7, hopefully we know that we're adding 2. So the change on the x side is a positive 2. So I know that my slope is negative 3 over 2, or the same way to write it would just be negative 3, 2, 3 over 2. Oop, thirds. Because that negative doesn't necessarily apply to the this section here of my slope or the bottom. It could go to either, but the point is that it's a negative slope. That's all that matters. Okay. I'll go over to number 6. Number 6, I have again the points given in the table lie on a line, and it says find the slope. And since we're looking at a table, we know that we want the change of y over the change of x. Look at the y's. I'm asking myself, start at 3, and then I want to go to a negative 1. And then from a negative 1 to a negative 5, and then negative 5 to a negative 9. Now, I understand that this process right here might be a little difficult once we get into, negative integers and then positive integers. But if we can't do this, we can always work backwards, right? We can start off with this guy and then see what the difference is from going and starting here with the 3. So the way that we do this in our calculators is this is a negative 1, so I'm going to put negative 1. And I want to find the change or the difference between the guy that was on top, which is 3. And then you see how I get negative 4. So the change from 3 to negative 1 would be a minus 4. I'll do the same thing and work backwards in a sense. I want to know what the change is between negative 5 to negative 1. So I can put negative 5 first, and it's always with the number that's on top. So minus negative 1. And since it's a negative 1, I'm going to put that in parentheses. So that way the calculator does exactly what I want it to. And see how we get negative 4. And the next one would be the same thing, negative 4. So now I know that my change here for the y is a negative 4. Then I ask myself the same thing for the change in the x side, right? I want to go from a 1 to a negative 7. But maybe we can't do that in our head, so let's work backwards. We start off with negative 7, since it's the bottom one, and we want to find the change, so subtract, with a positive 1. And then what do we get? We get negative 8. Same thing, we want to go from negative 7 to negative 15. That was an ugly arrow. But we want to work backwards. Let's say negative 15 is first. Find the difference. And the number on top is negative 7. This is a negative 7, so I'm going to put that in parentheses. And we get negative 8 again. And it would be the same thing for the next one. So the change in x is a negative 8. And again, our slope, we always want it to be in its simplest form. Our slope right now is negative 4 over negative 8. And maybe again, we can't do that in our head, so let's just type it into our calculator and see if it can be simplified. All I'm doing is putting the changes that I had in both into my calculator and see if it simplifies. It does simplify to a positive 1/2. So this here is my final answer. Okay. Number 2, finding the slope from points using slope formula. Right? Here we give you a formula to find slope, which is slope is equal to y over 2 minus y over 1 all over x over 2 minus x over 1. Now I know this sounds a bit, confusing, but let's say I gave you these points here. Let's say I gave you 3 and 6. It's so ugly. Let's say I gave you 3 and 6. And then let's say I gave you a second point of 2 and 4. By 8th grade and hopefully doing those extra credit graphs, we now know that the first number is my x, right? My second number is my y. So I'm going to go ahead and label this x, and this one here would be y and y. Right? In the alphabet, the x comes before the y. Think about it that way. Now I'm going to label this my first set and then my second set. And all I'm going to do in order to get this formula going is, since these two are in my first set, I'm going to put this to be x of 1, y of 1. And on this one, this is my second set, so this is going to be x of 2 and y of 2. And now with my formula, now it all makes sense, right? My formula here, let's say this was my problem. I would be going off to the side here. First thing it says is y of 2. I go over to this. Y of 2 is under 4, so I would put 4 minus y of 1, which is 6. So I would put minus 6 here, all over x of 2. X of 2 is here with a 2, minus x of 1, which is the 3. And then I would solve from here. Okay, so hopefully that gives you a little bit of a better understanding and we can actually dive into these problems now. So number 7, it says find the slope of the line that passes through each pair of points. Okay, so I'm going to label these guys. First, I have my x's. Goodness me. My x's come first, so x. And then the second number is my y. And I'm going to label this guy my ordered pair of 1 and my ordered pair of 2. So now this is x of 1, so here, and this y belongs to the first set, so this is y of 1, x of 2, y of 2 because they belong to the second set. My formula is right here for you guys. You can still see it. First thing we want to look at is y of 2. So slope is equal to y of 2, which is 3, minus y of 1, which is 4 on this one, all over 2, which is at 2, minus x of 1, which is at negative 3. And since it's at a negative 3, I'm going to put it in parentheses, just like so. Now we could do the math real quick and do this in our heads, but just in case, I can put all of this into my calculator. So we start off with our fraction bar. Oop, fraction bar here. On the top, I have 3 minus 4. And then I go down to the bottom, and I'm going to put it exactly how it is. 2 minus a negative 3. Exact same thing here to my calculator. Hit equals, let it do the math for me, and we'll see that we get it all simplified down, and we get slope is equal to negative 1 over 5 as my final answer. Okay? And now, you don't necessarily have to do this part every single time, but it does help. So I like to do it just because I'm a visual guy and it's all second nature for me, so I can move quickly. The formula is y of 2, which is at 5, minus y of 1, which is at 3. So 5 minus 3. And then x of 2, which is at 2 again, minus x of 1, which is at 3. We do this in our heads. 5 minus 3 is 2. 2 minus 3 is negative 1, which simplifies down to slope being negative 2. Okay. Number 9, same thing. Going to label my points, x of 1 and y of 1, x of 2, y of 2. Y of 2 goes first, so 8 minus y of 1, which is at 3. And then I got negative 2 is at x of 2, so I'm going to put negative 2. Since it's at the beginning, I'm not going to put it around parentheses. But notice that the x of 1 does have a negative 2. And not to get it confused with my other negative, I am just going to put that guy in parentheses. Hopefully it looks like the computer froze. I think we're back. So let's go ahead and type this one into our calculators just in case. So 8 minus 3, then we get negative 2 minus a negative 2. We get a math error. Now, why do we get a math error? Right? Our calculator's doing it for us, but let's just double check. 8 minus 3 is 5. This is negative 2 minus negative 2, which is like saying negative 2 plus 2, which is 0. And we know that we can't get a 0 down here. When we get a 0 down here in our slope, it means that our slope is what? Undefined. So here, slope, don't necessarily have to put m is equal, you just put undefined as your final answer. Okay. Number 10. And I'll give you guys a nice little head start. Since I'm not putting it on Edpuzzle, I'm going to give you guys a nice little run and try to see if we can solve it real quick. Here, x of 1, y of 1, x of 2, y of 2. 4 minus 4, x of 2 is negative 4, x of 1 is 8, so minus 8. 4 minus 4 is 0. Negative 4 minus 8 would be negative 12. I get 0 all over negative 12. Put that in our calculator just in case I don't know it again. And we get slope is equal to 0. But on the contrary to this one, see where our zeros are at? My 0 is on top of my slope. So that means it's automatically just 0 like it was here. Right? Number 11 is asking which of the following would result in the steepest line. Now in the beginning, we didn't really talk about it too much, but we said that the greater the slope, and then these lines right here, this is absolute value, right? Absolute value is saying if I were to have a number line and say, what is the absolute value of negative 2? And I show that by putting bar and bar. What I'm asking you to find is our point is here at 0, then this would be negative 1, and then negative 2. Absolute value tells me how many points away is this number, negative 2, from 0. And our answer is always positive. So negative 2 is here, and we're asking for the absolute value of negative 2. We're looking at for the opposite, which is going to be a positive and just be 2, because it takes me 1 unit, 2 units to get down to 0. Okay, so with that being said, let's look at these guys here. Our options are negative 2, 1, and 1/2. So we're looking for the absolute value of negative 2, absolute value of 1, and the absolute value of 1/2. We just did this in our example. The absolute value of negative 2 would just be 2. The absolute value of 1 would be 1. And the absolute value of 1/2 would just be 1/2. And the steepness of a line, the greater the slope, oop, where am I at? The greater the slope, the absolute value of the slope, the steeper the line is. So we're just being asked, what number is the greatest between all of these absolute values? Hopefully we can tell that the 2 is the greatest, so it means that -2 has the steepest line. And the last part, don't forget that it says to explain or why. Looks like I froze up again. Let's go, let's go. And the reason why is because it has the greatest, oh my goodness, hopefully you can still hear me, but the greatest absolute value. There we are. Looks like we're back. And that's just your reasoning. Number 12 says, explain why the slope is always the same between any 2 points that is non-vertical. Right? Non-vertical would be like this guy here. This line here. Why is the slope always the same and doesn't change? Meaning that this line, it has one speed and it never changes. If it were to change, let's say we speed up, and we'll learn about this later on. Let's say we start going and then it drops down, then we can tell that our rate of change changes at this point here. But when it's a non-vertical line, this is obviously I didn't use a ruler, but this line is technically going on forever at the same speed. So to answer the question, explain why slope is always the same between any 2 points on a non-vertical. It's because the rate of change is constant, meaning never changes. It's at one speed, one full send, boom. All right, that's our notes for the day.